Hey everybody, how you doing? It's Vicious, and it is the middle of the day on Friday, October 31st, so it's Halloween. And today, in the middle of the day, we're doing a video on a Cisco certification lab. We're going to be using GNS3, which is a free emulator for the iOS system that you can download, and then you have to find your own iOSs to plug into it. The lab we're running through today is one made by somebody else, and I'll just be running through it with you. And it's the guy who runs the site GNS3Vault, and they have a lot of good free labs on here. And I'm kind of at the point right now where I'm doing these intermediate labs, kind of practicing and getting ready to take my ICND2 test, which will give me my CCNA certification. I just took the ICND1 last week, and I did really good on that, so I'm officially a CCENT right now, but no one really brags about that. I'll be a little bit happier to call myself a CCNA in about another week or so. So the website is GNS3Vault.com, and I'm under the labs section, under the CCNA routing and switching, and then I grab the OSPF lab. And you download the topology. You have to register for the site, but it is free. And then we're going to go through all of these goals for that lab. Now the guy already has a video solution on here, so you are more than welcome to watch his video if you would like. He'll go a lot faster than me because he's much better at this than I am. Also, it's his lab and he knows it like the back of his hand. But if you happen to like my voice better than his, or you want to go a little bit slower and I'm going to try to explain just a little bit more, then you might want to check out this video. So I'll slide that over. I already took a screenshot of our goals so we can throw that on screen a little bit easier. Let's go ahead and kick off GNS3 and get started with our lab. And I had some trouble setting this up today because apparently there's a new and old version of GNS3, and these lab files work with the older version. I'm using 0.84. If you get the new 1.1, this doesn't work. And there's supposed to be a converter for it, but it didn't work for me. So keep that in mind if you want to try to copy this, that you want to probably download the older version of GNS3. So we got all of our setup here. I did correct a typo. This is OSPF area 1. We're going to be configuring a multi-area OSPF network here. And let's go ahead and start all these routers up. Now keep in mind that this is my very first video of this type, going through a lab like this. If you like these videos, let me know and I'll try to do more of them. You can kind of point me to some labs you'd like me to try out and do those on the air. Also, I'm thinking about doing like a basics series to kind of go over the information I've already learned to pass the ICND1, like subnetting and such. There's so much material out there on the internet. I mean, there's tons. Obviously, I had to learn from somewhere, but once I've collaborated all that information into my head, I kind of know the best of everything that I've learned, and I can kind of put it in one place for you. So I think it might not be a bad idea to kind of give you guys a little tutorial on some of that stuff that I've already learned. We'll go ahead and connect a console to each and every one of these. We're using putty as our console connection, and I've changed the colors to green. That's my favorite color, and I made the font larger so it's easier for you to see on the video without going a full screen high resolution. And let's go ahead and take a look at our goals, shall we? The very first thing it lets us know is that all the IP addressing is already done, so we're not doing that. And also that they have a loopback interface on each router as well. This helps us identify them. The first thing we have to do is configure OSPF area 0 on Durden, Paulson, and Chesler, which are the three routers here. Then the second thing that we're going to do is configure OSPF area 1 on, it says Bird, Dent, and Singer. It doesn't tell you in the directions, but you should be able to tell from looking at the topology that this guy here, Chesler, is our ABR, area border router, and he's both belonging to area 0 and area 1, so we actually have to configure him for both. So if you're going directly by the instructions, you wouldn't put him in area 1 and you would have a broken lab. So let's go ahead and start by going to Durden. Now we're going to go into enable mode, and we're going to go into configure terminal. I will be doing this a ton in the lab, so I'm going to go show IP interface brief. This gives me do show IP interface brief. This gives me a way to see what interfaces are in use and their IP addresses. This helps me know where we're at as far as the topology. So I can see that we've only got the one interface here, and we have the 2 loopback interfaces. So we're going to go into configure the router for OSPF, and we're going to use process ID 1. You can use any process ID you would like. Just know that when you come back to modify your OSPF settings, you have to remember the ID you use. So most people go with number 1. And then to broadcast and add this to our OSPF routing, we need to use the network statement. Best practice from Cisco says do this. Go exactly the IP address that you're looking for to add, and use a zeroed out wildcard mask, which means it's only going to look for this interface and add it to OSPF. The lazy man's way of doing things, when you're, especially for labs, is to use network, and then you can do the exact opposite. Just use a zeroed out network and a full 255 wildcard mask, and this says match any network that I have on this router and add it to OSPF area 0. So all 3 of those interfaces are now in OSPF on Durden. We'll move on to Paulson. Enable, configure terminal, and we're going to go router OSPF 1 network 0000255. Alright, so he is done as well. I'm going to skip over him. We'll come to him last, Chesler. We'll move on to Singer real quick. Okay, so don't make a mistake here and type area 0, because it's kind of a secondary habit you'll get into once you do this too many times. You got to remember that we're doing multi-area, so we're going to use area 1 when we add him to OSPF. And we're going to go to bird. I might have to move my mic for the next video. I can hear that typing going through pretty loud. So area 1, and then Dent as our last router in that area. And I'll let that one sit there so we can see our OSPF adjacencies coming up here for our neighbors. At this time, we haven't made that connection between our areas yet, so if I was to do like our routes, we're only going to see the routes that we learned in area 1, and we haven't gotten anything from area 0 yet, which is our backbone area. So let's go ahead and pull up Chesler now. Okay, do show IP interface brief. We have 2 fast Ethernet interfaces. One's in the 123 network, one's in the 45 network. Looking at this, you see the 123 is our area 0 and the 45 is our area 1. So that's how we're going to have to put these in. So let's go ahead and go to router OSPF 1 network. And now I'm going to do the Cisco recommended way of doing this. I'm going to say network 192.168.123.3, and I'm going to use a zeroed out wildcard mask, and that's going to be area 0. And it's going to spam me with a bunch of adjacencies probably here in a second. Okay. Network, and we're going to use 192.168.45. And this guy is zeroed out, and he's in area 1. And now, as soon as I hit enter, we have a multi-area OSPF network, and we should have full routing between everything. I just need to also make sure I add in that loopback address. So network, and he's going to be in area 0. Okay. So let's go to a far router. Let's go over here to Dent. He's the furthest away from area 0, and look at the routing table. So our routing table now, we'll see that we have OSPF routes designated by the O. If we look at our key, OSPF, and we can see IA, and that means it's in another area, intra area, and there's somewhere. You see it, and I don't, because there it is, OSPF intra area. So that means this is actually in a different area. That's our area 0, and here's the rest of our routing table. And our goals, the next thing it tells us to do, now that we've configured area 1, we should have full connectivity. Make sure you can ping all the loopback interfaces. So let's get down to enable mode and ping a few of these loopback interfaces. As you can see, all our pings are going through. We have full routing now, so we're good to go on that. Let's pull up goals again. What's next? So we've done OSPF, full connectivity. It wants us to change the router ID of Singer to 444444, and make sure you can see the change by looking at the proper show command. So let's go to Singer. And we need to, we're already in the router config mode, so that's nice. We can just go to router ID, that's dash ID. And I'm using the question mark sometimes, and other times the tab key. Those helps me to fill out the commands easier. And we're going 44, 44, 44, 44. Enter. And the router is smart enough to warn you that your adjacencies are already built, your neighbor relationships are already built. So you just made a change that would change those relationships, and it won't take place until you either restart the router or manually clear the OSPF process. So we need to go back into our enable mode and type in clear IP OSPF process. And it's going to ask me to confirm that, because if you did this on a production environment, you would be just destroying things right now while everything's rebuilding. So now that we've done that, we can do a show IP OSPF protocol. No, just show IP protocols. And we can see the router ID for this router is 444444. So we accomplished that goal. Next up, says what router is the designated router, the DR, and the backup designated router that is connected to switch 2? Can you explain why? All right, so switch 2, because we have 3 routers connected to each other, what OSPF does is it will only broadcast updates to the routing table from the designated router and backup designated router, and that's to prevent too much traffic jam, like chaos happening, where every single router is trying to send all these updates. And this is only 3 routers, not a big deal, but if you're in a huge environment where you have maybe 40 routers, every time a router sends an update to another router and then another router, it's just a nightmare. So that's what this exists for. I'm going to pull up Singer here, and we're going to do a show IP OSPF neighbors command, and it tells me that the 555 ID has the designated router role, and that the 333 ID has the other role, the druther role, which means he's not the designated router or the backup designated router, and therefore through elimination we know that the router we're on has the backup designated router role. So let's do a show IP protocols. So router ID 444444, this is our backup designated router, and I can tell you that the election for routers only takes place when these relationships are building. So it's still taking into account right now our idea of 4444, the original one, which is why we're the backup designated router instead of the designated router, because this the election goes from router priority, which you can see we're all priority 1, and then it goes to router ID as the second tiebreaker, and 4444 fell in the middle, and that's why it was the backup designated router. But now that we have 444444, we should actually be the designated router. If we were to reboot all of these routers, that's what would happen. So that's the why and how you figure it out. What's the next thing it asks us to do? The change the network so that Chesler will be the designated router. test this by resetting OSPF and using the show commands. You need to find it. So they want us to actually make Chesler the designated router for this segment here. This will be a little bit confusing to show because it is on both area 0 and area 1. So it could be the designated router for both areas, or it could be the designated router for one or the other. So you have to make sure you look at the information properly. Now let's go ahead and go into Chesler. And Chesler. So I told you it goes off of priority and then by router ID. So as the first two fields that are going to be determining whether or not this is going to be the designated router, I don't want to change the router ID to win that election. So what I'll do is I'll change the priority instead. So we're going to go to it's actually going to be on the interface, if I'm not mistaken. This is why I'm teaching you guys, because I can learn while I go. So let's see, we're going to be looking at fast Ethernet 1.0, so interface fast IP OSPF priority. There it is. And I'm just going to give it a higher priority than 1 is all we need, so I'll just make it 15. And now we change the priority. We're going to have to do the clear IP OSPF process on that router, and we're going to use Singer as our demonstration to make sure those changes worked. So let's do this again. Let's do a show IP OSPF neighbors, and you can see that the DR is still the 5555 because we need to rebuild that OSPF process. The priority is showing, but the election hasn't taken place. So clear IP OSPF process. Let's let that sit for a minute. And now let's look at our neighbors again. Still has not gone through. And let's go ahead and do that on bird as well real quick. All right, back to Singer. Let's look at our and there we go. So we have the lower ID but the higher priority, so now it took over as the designated router. So that's how you accomplish that goal. Now moving into the next goal, let's see, designated router, we did that. MD5 authentication on the serial link between bird and Dent. So Dent and bird are down here in the bottom of area 1. And our serial link between the two is serial 10. So we want to enable IP OSPF authentication message digest. That turns on the authentication. Then we need to set our authentication OSPF authentication key. Nope, that's incorrect. IP OSPF message digest key. And then key ID number 1. And then MD5. And then we'll use Nikon, because I'm looking at my Nikon camera in front of me. So that's going to set up bird, and we just lost our adjacency because we have authentication on one side and the other side is not authenticating. Let's go back and pick up Dent and fix it. This is probably also serial 10. It is, so we're going to do IP OSPF authentication message digest IP OSPF message digest key number 1 MD5 and icon. I'll sit tight for a second and watch that adjacency come back up if everything's working. And there we go. So we have MD5 authentication between those two now. Our next goal, it's asking us to enable plaintext authentication on the fast Ethernet link between Bird and Dent. So the same two routers, they have two links between them, one serial, one fast Ethernet. So we're going to use the fast Ethernet interfaces this time. And I think that's fast Ethernet 00. It is. Okay, so 56. I better make sure we're on the right one. We need the, yes, 56. So fast Ethernet 00. So now we're doing IP, OSPF, authentication, and that's that for turning on the authentication. Then now the authentication key. And that's that. That'll take down that interface in a moment. And we'll hop over to Dent. Okay, so we're going to need interface fast 00. And it just went down because the dead timer got matched from timing out. And we'll bring it right back up. And there we go. So that goal is now completed as well. Alright, next, make sure all routers in area 0 are sending hello packets every 4 seconds. And if they don't hear anything from the neighbor after 17 seconds, they should drop. So that's our hello interval is the 4 seconds. And our dead interval is 17 seconds. They want this only in area 0, so these three routers, Durden, Paulson, and Chesler. Let's go to Durden first. And exit out of that. Interface, fast, Ethernet 00, IP, OSPF, hello interval, and they wanted 4 seconds. IP, OSPF, dead interval, and that was 17 seconds. So that interface is done, and that will break the adjacencies on that router here shortly. Let's go to Paulson. Flow of 4. You just saw the adjacency went down like I said it would. Dead interval of 17. That'll bring it back up. There we go. And now we need to go to Chesler. Need to make sure we get the right interface. We need the one in the 123 network, which is 00. Interval of 4 of 17. So that should have everything going. Let's do a show IP neighbor command. And I see 2, 1. Yep, everything looks like it's there. Our next goal is to advertise a default route on Durden and OSPF. Test this by checking reachability of its loopback 1 interface from the other routers. Do not advertise the loopback 1 in OSPF. So we're going to Durden now. Durden up here at the top. Now, if you remember, when we did this configuration earlier, I'll do a show run for you guys to show you the running configuration. And let's go to our OSPF section. We did the lazy man's OSPF here, where we added every single interface into our OSPF advertisements. And so now we're being told exclusively to make sure we don't include that loopback interface, so we have to undo that. So let's show you how you would do that. We'll configure terminal, router, OSPF 1, no network, 0, 0, 0, 0, 255, 255, 255, 255, area 0. I'm going to look at my interfaces and I'm going to add them exclusive now. So let's do network 192.168.123.1, and that's area 0, network 1.1.1.1.0.0.0.0, area 0. Okay. So those two are now advertised in OSPF, but not the loopback one. So let's verify that. Let's go all the way over here to Dent. Verification is always very important. Let's do a show IP route. And I should see the 1111 in here, which I'm not right now. There it is. It just took a second to come through. So we have the 123 network. We have the 1111 because we added those to the OSPF advertisements, but we do not have the 11. So if we try to ping to that, you can see it's going to fail. So what they want us to do is to go over from Durden and add a default route. So you do this by default information originate. This is basically saying if I have a default route, I want you to add it to OSPF as me originating as the source. And we don't have any default routes set up on this router, so what we have to do is use a keyword always. And it basically says, make me the default route for everybody else in this OSPF environment, even if I don't have a default route. So we'll type that in. Now we'll go back over and look at Dent again. And the first thing I'll do is I'll show you the routing table. See if it got here that quickly. Yep, see, we have the asterisk here. This is letting us know this is a default route and is sending us out towards the next hop to get to that router. So now if I ping 11.11.11.11, it'll get there. And the reason is not that it knows where 11.11.11 is, but anything that's not in its routing table, it's going to go here. So it ends up reaching that interface because that router is the last resort. And now let's jump back into the goals. What do we have left? Configure Dent so it will load balance over the serial and fast Ethernet link for all networks. OSPF can do equal cost routing. So if you have more than one link to get somewhere of the exact same cost, it actually does a rudimentary load balancing and helps equalize that traffic across your lines. You can see that the serial link and the fast Ethernet link are here, but they are they're not going to load balance normally because they're not the same cost. You have to have equal cost. Only EIGRP can do unequal cost load balancing. So let me show you the interfaces again. It should be fast 00 and serial 10. Okay, so let's do a show IP OSPF interface fast Ethernet 00, and this gives us our details. The cost of that link is 1, and if we do a show IP OSPF interface serial 10, the cost of that interface is 64. So that's the reason why this serial is considered much slower and it's a higher cost due to the way the metric works for OSPF. So we'll go into those interfaces. IP OSPF cost, and we'll set it to 15. And we'll set this also to 15. So now we just equalize the cost of those interfaces, and OSPF will take over and automatically do load balancing. Let's go show our routing table again. And now every single route has both interfaces on there because it's doing load balancing for us. And I think that was it. Was that the last one? It was. So that is the end of this. Let me see. Let me pull up my recording real quick and see how long it took us to do that. It looks like I don't see a time actually. But that was the first video of running through some of these labs. So if you like the way I went through it, my pace, the way I talk about things, explain things, hey, say thank you. Let me know with a thumbs up in the video. Put some comments, some questions, whatever you have. If you have any suggestions on how to make it better, that's great. Let me know. You know, explain things more, slow down, speed up, do this lab. Just let me know, because without your feedback, I can't know. So it was a really good idea to get up and do this today. Hope you guys enjoyed it. This was Vicious, and I'll see you next time.